Message to self. When you're fooling around with things that have the potential to fail catastrophically, and especially when you're pushing them to their limits, film it so that you've got some evidence to work from for the autopsy, or if nothing else, something to make a YouTube video out of. Yeah, wish I'd followed that advice. This here is my development jig for these two OPA 541 based power amplifier modules. They can take up to plus and minus 40 volts and output currents of up to 10 amps, 6 continuously, I think 10 sometimes. And I've seen a few videos on them, and yeah, the heat sink on them is a problem, so there's fans blowing straight onto them, and on top of that the circuit board stopped the flow of the air. I won't show you, but I've just drilled out all the space between them, between the pins, and broken off the circuit board underneath so that the air can blow out the bottom as well. And it's actually going through a hole down to these two power supplies at the bottom. And I can adjust the voltage on the power supplies with these cute little knobs and displays. And yeah, so the purpose of this was to suss out exactly what I might want to put together to use these modules, and I'm pretty much decided I don't want to use them because they are a bit fragile, or not as robust as I thought they were. This is just running into this 100 ohm resistor. This module is the one that I was using, and I've blown it up. The chip is cracked. This one has always been a bit sus, but I thought it worked a bit. But there in the oscilloscope is what I'm putting into it, a sine wave, and here's what I'm getting out, just rubbish. I just didn't look into it closely, but I thought at least I'd have this one working somewhat so I could reproduce what I did to make this one blow up. And turns out I've just got two duds now. And instead of that, I was using this 4 ohm resistor, just maybe 100, 200 watts. The trick is to turn the power, that's why I've got these variable power supplies, to make the voltage going into these things no higher than it has to be to get your peaks on your sine waves, just to stop them clipping. More voltage than that and you're just wasting power as heat, in the difference between the output you want and the incoming voltage multiplied by the current you're drawing out. It's just wasted power if you're not running it up to the full voltage level. You don't need to take it up to 40 volts. If your signal's not going up to 40 volts, you don't need a 40 volt input power. So I can turn these down when I don't need that much voltage. That was all working pretty well. They get warm, but with the fans, and if you set the voltages right, they're not too bad, even though this thing got too hot to touch when I put a fair bit of power into it. And I had to put that, and that was getting too hot to touch when it was sitting there in front of the fan. But then I thought, okay, this is good. I'll do what I really wanted to do with all this stuff, which I'll set up now. Yeah, I wanted to make AC output voltages at anything from 10 volts to full mains voltage, and also be able to vary the frequency, which is why these amps were good. I've seen them used that way. You can drive them into a transformer. Here I'm using the midpoint of this isolation transformer. You can get to the 32 volt tapping between the two transformers. If I come in here, I can drive both transformers, but I'm taking the output here and feeding it into this dummy load, which is a light bulb. And I could wind it up. I was sticking about 4 volts peak to peak into the amplifier, and out of here I was getting nearly, I think this is why I should have recorded it, so I would have a record of it. I was getting nearly 240 volts out of here, I believe, and this light, which is 75 watts, was glowing fairly brightly. All seemed pretty good. And then I screwed down this 150 watt light to bring it into the load, and then bang, something snapped there and everything stopped. So yeah, that's what I wanted to do. But these things just, well, they're just not tough enough to be able to run them that hard, I don't think, and I want to be able to put fairly significant loads on it. So a bit disappointing. Went to a lot of trouble making all this. Now, they're probably good for when you need a power amp on your function generator, when you need more output than your function generator can provide, but there are limits. Where I'll bother getting, because these things cost like 38 bucks Australian each, and I just looked up the price of the chips, the APA 541, from the reputable suppliers. They cost 38 bucks just for the chip, which makes you wonder, are these genuine or fakes, and maybe the real chip would be able to do what I was trying to do, because it's supposed to have thermal shutdown, and this resistor here is for it to detect overcurrent and shut down, so I reckon it should have been able to survive. But perhaps the inductive load of that was causing kickbacks. So I was seeing it on the oscilloscope, and I didn't notice anything bad, but again, a video would have been helpful. I did buy all these transorbs and Schottky diodes to protect the amplifier from inductive kickbacks, but I hadn't installed them, because it'd be a bit of mucking around to wire that onto these things, and I think from what I was looking at on the oscilloscope, I hadn't seen any need for it yet. So maybe they would have saved things. I doubt it. I think these things are just too piss weak to handle it, and or they aren't genuine chips and lack the proper internal protection. Anyway, so thought you might find that interesting, humorous. So what am I going to do to continue with that line of experimentation? How am I going to get variable frequency and voltage power AC? Well, here's what I've decided to play with. A UPS, unit uninterruptible power supply, contains pretty much everything that I'd need to do what I'm trying to do. So I found this one lying in the street a few years ago. I haven't looked at it till the other day. And of course you've got the batteries, they're all stuffed of course. Control board, nice juicy transformer, and yeah, H-bridge to drive that thing, but you need a high current DC input. But still, I've got those in those power supplies there. So that you know, pulling the parts off of this and experimenting, I might be able to come up with something that does what I'm thinking. And I also had this other UPS lying around for years. I just had a look at that as well the other day. And that's this brute. All the batteries are gone, but yeah. But look at that transformer. Isn't that gorgeous? Huge high current primary in this case, because the volts go in there and they come out on the other side. Big control board up here. 4 H-bridge heat sinks. Each leg has 4 MOSFETs, I suppose that's what they are. Yeah, so there's stuff in there, but again, it needs a pile of incoming DC volts to go through a transformer, or via the H-bridge through a transformer to produce the output voltage. And because I want to go to be able to produce output at as high a frequency as possible, like the bandwidth on those amplifier modules was 100 kilohertz, maybe not that high, but I certainly like to be able to put out 10 kilohertz reliably, and being an iron core transformer, these things probably won't work at that frequency. That'd be pretty bad. So is there another way to do it? So I bought some junk. Yeah, I got these big brutes, only like $15 each. There's 2 of this model and 1 of this. I think they're about 3 kVA output as opposed to this little thing, which is about 1100 watts, 1100 VA. But yeah, let's see what's inside it. Lots of stuff. Lots of big inductors. And I think the batteries for this were external. But yeah, Wow, so it's going to take some sussing out. Can't find any useful documentation, certainly not schematics on these things. So I'm going to have to just do a lot of research. I've got to learn a lot about how these things might work and dig into them closely. But if you'll notice, there's no big transformers. So I believe these things are what's called high voltage inverters. So they take the incoming mains that you're trying to protect against interruption, and they convert it to DC at a high voltage, say 200 volts, and then go through another converter that turns that DC into AC output. And that last stage can take its input from batteries, and if you get a string of batteries in series, you can make 200 volts. I think that's how they work. So, 200 odd volts coming from the incoming mains, 200 volts from the batteries, and the output inverter can use either of those two sources of high voltage, something like that. So, that's a good way. If I just so this contains pretty much what I want, I think, except for being able to fool around with the frequency and voltage, and plus no schematics. So the parts I need are probably in here. I've just got to work out what to do with it all. So that's one of them, and I've got two of this type, and that's where the batteries go. I'm not sure if these are the same. I don't know how you can get a 200 odd volts out of the number of batteries you could fit in there. So again, more research required, and not quite as much electronics, but you thought those other things had an inductor? That's an inductor. That's a brute. So there's less electronics in this one, and I've got at least user manuals for this model, so I can get an idea of how it's supposed to work and maybe suss out what's going on inside of it, but no service manual or schematics. But okay, that'll keep me busy for quite a while. Hope you found that interesting. Catch you later.